Data sources are fundamental components in Azure AI search architecture. They define the connection to your raw data and entail the essential parameters Azure Search needs for data ingestion. Data sources allow Azure AI Search to integrate seamlessly and continuously update indexes with modifications in source data, maintaining an updated and relevant search experience. Common data source types supported by Azure AI Search include Azure Blob Storage, Azure SQL Database, Cosmos DB, Azure Table Storage external or third-party cloud services. Creating a data source in Azure requires providing detailed connection information to your data storage. This setup enables Azure AI Search to connect securely and effectively extract necessary documents or records continuously. Configuration typically involves data source name source type selection, e.g., blob storage, Cosmos DB, connection string or credentials specific parameters such as container or table name. Implementing the correct configuration ensures optimized data crawling operations, comprehensive document coverage, and enhanced index efficiency. Connection strings and data sources securely define the pathway Azure AI Search uses to connect with the data storage. A typical connection string might look like this for a blob storage. JSON default endpoints protocol equals HTTPS. Account name equals storage account name. Account key equals storage account key. Endpoint suffix equals core.windows.net for accessing databases. Connection strings include authentication details needed by Azure to execute authorized data retrievals efficiently and securely. Secure management of these strings using Azure Key Vault is recommended to maintain high security standards. Security is paramount when configuring data sources, ensuring data privacy and compliance. Azure AI Search supports multiple authentication methods to safeguard connections between Azure services. Essential security strategies include role-based access controls, RBAC, managed identities for secure and simplified resource authentication, Azure Active Directory, AD. Authentication utilizing Azure Key Vault to securely store authentication keys and secrets is recommended as a best practice to secure sensitive information effectively. Indexers are automated services provided by Azure AI Search responsible for crawling your data sources. They extract documents, transform and enrich content if needed, and update search indexes automatically. Indexers handle data ingestion from various formats, pre-processing content based upon defined skill sets for advanced processing like OCR, NLP, or sentiment analysis. Frequent, scheduled runs ensure that search results remain accurate and reflect the newest data and changes. Configuring an Azure indexer involves specifying how data is managed and ingested into an Azure AI Search index. Key configuration elements include connecting indexers to specific data sources, mapping data fields from source to index fields, setting scheduling details to automate indexing intervals, defining skill sets to enrich content. Indexer configuration enables periodic updates, automatic error handling, and integration with external processing skills, ensuring consistently accurate indexes. Field mappings are essential in configuring indexers. They explicitly align data fields from the original data source to designated fields within Azure AI Search indexes. This process ensures data consistency and accuracy within the search index. Field transformation is the capability to modify or alter data during field mapping, converting formats, applying data normalization, or extracting entities. Transformations improve data utility for enhanced search results by ensuring data fields are fully optimized for querying operations. Once an indexer has been configured, it is necessary to run it manually for initial ingestion or automatically at scheduled intervals for continued syncing. Monitoring is critical for maintaining indexer performance. Azure AI Search provides various monitoring tools and insights, allowing administrators to evaluate successful ingestion rates, errors, questioning data quality concerns, or performance bottlenecks. Azure provides metrics such as indexing duration, records indexed, and potential failures, accessible via the Azure portal and APIs. Scheduling indexers allows automatic ingestion of data updates according to defined schedules. Schedules can be customized based on data volatility, whether changes happen frequently, hourly indexing, or infrequently, daily or weekly. Indexer scalability should consider factors such as data size, ingestion frequency, and available computing resources. Optimal resource allocation and scheduling enhance scalability, enabling Azure AI Search to handle significant data volumes efficiently without compromising performance. Error handling in indexers ensures that your indexing processes remain functional, even with problematic data. Azure AI Search provides built-in capabilities such as detailed error logs highlighting failed records, retry logic, and configurable retry intervals error limits, which control termination of failed indexer runs by analyzing log data. Administrators can rectify source data issues quickly, manage data exceptions proactively, and improve overall indexing reliability and quality. Skill sets empower indexers with cognitive capabilities, enabling advanced data extraction and enrichment. Skills available include optical character recognition, OCR, named entity recognition, NER. Sentiment analysis associating skill sets with your indexer enables richer data ingestion. This integration allows automatic application of complex processing over data, making content searchable at higher semantic levels and significantly enhancing search outcome quality. Adhering to best practices optimizes indexer configuration, ensures efficient indexing processes, and enhances cognitive integration capabilities. Optimize indexing schedules according to data change frequency. Utilize managed identities for secure authentication, regularly monitor performance and error logs, incrementally index changes rather than full data loads to improve indexing efficiency. Secure, sensitive configuration values using Azure Key Vault. These practices support the creation of powerful, reliable, and secure AI-driven search services.